Hello everyone, this is Shilpi Saxena. Welcome to my channel Learning Hub. So in this video we will understand what is deadlock and what are the necessary conditions for deadlock to occur. So we will first take an example. Suppose there are two students, student 1 and student 2, student 1 and student 2. So student 1 has completed question number 1, 2 and 3, and for completing 4, 5, 6 he want help from S2 who has done 4, 5, 6, and to complete his work he want 1, 2, 3 question from S1. So in this case both are waiting for each other to give his notebook. So both of them will not be able to complete the work because both of them want other one to give the notebook to complete his work. Fine. So this is the condition of deadlock. Similarly, in this case, suppose a student, transaction 1, this is the resource. This resource was held by transaction T1 and he is demanding grade. This resource, okay, and which this resource was held by T2 and demanding student. So in this case, this to complete for T1 to commit, T1 needs grade. For T2 commit, T2 needs student. So both are waiting for each other. This is the condition known as deadlock. The deadlock is a condition where two transactions are waiting indefinitely for one another to give up blocks. Because when the transactions are in process, it will lock the resource. The resource will be locked and it will be waiting for another resource which was held by transaction T2, and it was waiting for a resource which was held by T1. So this is the condition of deadlock. Well, this example can be explained by this transaction. See, T1, T2. It is using A, so it will lock it. It has to read and write. Now it want to write on B. Now it want to write on B. For that it has to lock it. But to lock it, it should at a time only one transaction can lock. And this lock was already done by T2. So to complete that, it has to release, this lock should be released by T1. So, but it is not possible. So T1 is waiting for T2 and T2 is waiting for T1. See, it is waiting for lock A, which is locked by T1. So this one is waiting time. Both the process completed individual work on individual file, but it is asking to give another file. So necessary conditions. First condition is for deadlock to occur, all the conditions should be true. Okay, for deadlock to occur, all four conditions should be true. So first condition is mutual exclusion. Mutual exclusion means the resource is shared in mutually exclusive manner. Means only one resource will be used at a time. Means two process cannot use a particular resource even if it is reading or writing. So it has to lock the resource, and one resource will be used by only one transaction, one process. The next one is hold and wait. So there must be a process which holds some resource and wait for resource to be held by some other process. If suppose hold and wait condition is there, means it is holding a resource and waiting from some other resource, some other process to release the resource. In that case, deadlock will occur. Next condition is no preemption. Preemption means first complete the work and release the lock. Complete the work and release the resource. If it will not release it, if no preemption is there, preemption means completion and releasing of lock. No preemption means if the process is not releasing the lock, in that case deadlock will occur. Circular wait is like weight, it is just like hold and wait. The condition is it is cyclic in nature. For example, suppose P1 is waiting for P2 to release the resource, P2 is waiting for P3 to release the resource, P3 is waiting for P4 to release the resource, and P4 is waiting for P1. So each and every one is waiting for each other to release the resource so that they can complete the transaction. So this condition is circular wait. So if all four conditions occur together, it is deadlock. Means all the four conditions are true, then deadlock will definitely occur. Next topic is methods of handling deadlock. The first one is deadlock ignorance, not avoidance, ignorance, that is ostrich method, also known as ostrich method. So this ostrich method means ostrich is a bird. You know, you must be aware about this bird. So during the sandstorm, it puts its neck under the sand, so that it puts its head under the sand, so that it may feel that sandstorm is not there at all. So it tries to avoid the the sandstorm. Similarly, if deadlock has occurred, in that case we are also ignoring the deadlock as if it has never occurred. Rather than curing it, rather than coming out of this deadlock, we will try to ignore it. This is the first method. The very good example is, suppose your mobile hangs. Yeah, so suppose your laptop hangs. What do you do? You just restart it. You just hibernate it. So we are avoiding the deadlock basically. Next one is deadlock prevention. Prevention is better than cure. You must have heard. So what we will try to do, that you have already learned that for a deadlock to occur, four conditions should be true. That is mutual exclusion, hold and wait, no preemption and circular wait. अगर ये चारों condition true होती हैं, then only deadlock will occur. So if we will try to avoid, if we will make any one condition false, so deadlock will not occur. Any one condition false, then deadlock will not occur. So this is deadlock prevention. Next one is deadlock avoidance. We will try to avoid deadlock. Means if at all we feel that deadlock may occur at any point of time, we will stop the transaction, we'll roll back and start it again, so that deadlock is avoided. Now, last method, deadlock detection and recovery. If at all deadlock occurs, then the thing is, we have to detect that deadlock has occurred and we will then start recovering it. Now, the deadlock detection types. Two deadlock detection types: single instance. For single instance means if one process have one resource, means it may have multiple resource, but resource must be one in number of one type, like one CPU, one printer, one hard disk. Means if the resources are one in number, then it is single instance. If they are multiple in numbers, multiple CPUs, multiple printers, multiple scanners, then it is multiple instance. So if we have only one instance, so how we will detect deadlock? See, this is resource allocation graph. First of all, we will learn about how to draw resource allocation. So the rule behind drawing resource allocation graph is, suppose P1 is requesting, P1's want a resource R1. So we will draw arrow from P1 to R1, and this resource is already allocated to, suppose, P2. Processes are denoted in circle and resources are denoted in rectangle or square usually. Fine. So whenever the process, suppose process P3 is there, which is requesting the resource, so the arrow will be drawn from P3 to R1. If suppose R1 is already allocated to P2, so the arrow will be drawn for R1 to P2. In this way, the resource allocation graph is drawn. You can see this graph. In this graph, so P1 is requesting this resource R1, which is already allocated to P2. P2 is requesting R4, which is already allocated to P3. P3 is requesting R3 and R3 is allocated to P4. You can see, you can study this graph easily. Now, using this resource allocation graph, we will draw this wait for graph. Using wait for graph, we can find whether deadlock has occurred or not. So, very common question which is asked in GATE exam or in any of the university level exams, they will give you resource allocation graph and they will ask you to draw the wait for graph. So now we will learn how we will convert this resource allocation graph to from resource allocation graph to wait for graph. So for converting it, what we are going to do is see this resource. P1 is demanding R1. R1 is allocated to P2. It means P1 is dependent on P2. It means P1 is dependent on P2. When P2 will release this resource, then only P1 can execute. So, in this case, we will draw P1 to P2. We will draw from P1 to P2. Fine. Now, what we are going to do? Next one, P2 is demanding R4 and R4 is allocated to P3. It means P2 is dependent on P3. P2 is dependent on P3 already drawn. Now P3 is demanding R3 and R3 is holded by P4. Yani P3 is dependent on P4. So P3 is dependent on P4. Similarly, P4 is dependent on P1. P4 is dependent on P1. So in this case, we have to now see that cycle is formed or not. Cycle is formed or not. See the arrow, all clockwise, clockwise, clockwise and clockwise. If this cycle is on either clockwise or anti-clockwise, means cycle is formed, then deadlock will occur. This is the solution to that. Means if they are asking, draw wait for graph to see whether deadlock will occur or not. So because there is a cycle, it means deadlock will definitely occur. By any chance, if suppose one of the arrow is going from this way to this way, in that case the deadlock will not occur, because this way and this is in opposite direction. So deadlock will not occur in that case. But here which we have solved, so deadlock will definitely occur. Now Banker's algorithm is again very important topic which I'll explain in my next video. So if you like this video, please like and subscribe, hit the bell icon. Thank you and have a nice day ahead.